All right, audio fans, are you ready for a journey? Today we are diving deep into the world of Meridian audio, and it's a journey for me which began by tube and regional rail from central London, heading due north to a decently small town called Huntington. It's a trip that had me weaving my way through the underground, emerging at the cavernous King's Cross rail station you can see right there, traveling out through the urbanized grounds of northern London and its outer neighborhoods, ultimately arriving at a town that appeared to be surrounded by beautiful green pastures. And I'm told there are some really nice horse farms out there. It's just really beautiful country. And while on the smaller side as compared to London, it's this interesting hub of audio. You have Meridian, Audio Precision, the International Audio Group with Mission, Audio Lab, Quad, Castle and Orfandale are there, and Cambridge Audio and DCS are also nearby, which is a ton of audio technology crammed in to one little space. And I say little because really Huntington isn't all that large. It's about 26 or 27,000 people. And that brings us to the Meridian facility, which is just absolutely beautiful, just dripping with British pride. And you have to trust me when I say this, it's full of friendly and passionate people. Just really neat to see that. What you're seeing here is the front area of the building that houses a grand entry area and access to offices and conference rooms, and this ridiculously cool theater room that I was lucky enough to spend some time in. And here's a fun side fact. Those chairs that you see right there in the theater, they were pulled from Range Rovers that were used in a Bond movie. I think that's just really cool that they brought that kind of nostalgia into their home theater space. Now, beyond the front end of the building, the backside houses this serious top to bottom manufacturing facility, and we're going to dig into that in just a minute. But first, I just want to give you a little bit more background. Here's something you may not know about Meridian and its headquarters there. The building was actually built by Tag McLaren Audio, and when they stepped out of the audio game, I believe that was around 2004 or 2005, Meridian moved into the facility, and lucky for Meridian, they inherited a factory, offices, testing labs, including that home theater demo room I showed you, but there are also other listening rooms, an actual anechoic chamber, and in many cases, Meridian has just left things as they were when they took over the site. In today's video, we're going to stay focused more on the factory side of things, though I do have some video from an R&D room and the anechoic chamber, but I think I'll release that separately, so make sure you set up notifications just so you know when that video drops. Now, I mentioned listening rooms, and one of the rooms there at the facility had Meridian's new Elipse streaming speaker set up in it for demos, and boy, I'm so lucky that I got to hear that in action. I was floored by the sheer size and detailed nature of the soundstage it created. Perhaps astonished is a better word. If you haven't had a chance to watch my interview with Barry Sheldrick at ISE, where we dive into everything about the Elipse, I suggest you give it a watch. I'll drop a link to that right down in the description. But back to the speaker. You know, we live in this world where we have heaps of streaming speakers, and it's easy to become a bit jaded and make some assumptions about the capabilities of a speaker sized like the Elipse. And I say that without throwing any shade on Meridian. I've come to expect quite good sound from these types of speakers, but not extraordinary sound. But believe me when I say, listening to the Elipse had me looking around the demo room it was in, looking to see if other speakers were in play. It just had such a wide and active soundstage, just a wonderful little speaker. They've got something cooking there. Now, you might think the Elipse is a speaker that Meridian is building off-site, perhaps maybe somewhere where it can be mass-produced at a much lower cost, and then, simply slapping their name on it. But that's not the case. It, along with every other Meridian speaker, is handcrafted right there in Huntington. Folks, it's a special operation. Now, not every stage of the manufacturing process is done right there at the facility. They do have an off-site cabinet maker, and they also have a finishing facility that applies finishes to the speakers. But when I say most everything else is done on-site, it really is. And we're talking everything from making the PCB boards, to testing them, to having everything installed into the speaker, from the drivers to the electronics, and then testing those, packaging them up for shipping, and getting them out the door. Now, by the time you're done watching this video, and this is a long one, we're talking about 60 or 70 minutes of video, I think you're gonna have the same appreciation for Meridian and its staff that I gained while I was there. What you're about to experience is what I experienced. It's largely unedited. It's a full-on private tour with Des Ford, that's Meridian's technical marketing manager. Just a wonderful guy. He's been there for a long time and he knows everything that has to do with Meridian. Just a true encyclopedia of knowledge, which makes him a great tour guide. And now what you're gonna see is where things start with the PCB boards all the way through the entire manufacturing process. Now, I have made a list of bookmarks down in the description, so you can skip around if you'd like, but I encourage you to kick back and take advantage of this. Take it all in. I think you're going to learn quite a bit. Many thanks to everyone, and I mean everyone. You know who I'm talking about. Everyone at Meridian who welcomed us into their home. And with that, let's get things underway.
Like I say, yeah, this is the machine that applies the solder and flux paste to the boards, ready for surface mount components to be placed on top of them. It uses, really, it's like a screen printer that you'd print a t-shirt with, but in this case, instead of ink or paint, it's a paste of solder and flux that gets squidged onto the board through a precisely cut metal stencil, so that solder is applied just in all the tiny little places where the pads, the legs from the ICs and other devices are going to go.
That's really interesting. Are the boards pre-fashioned before they go into there? Or is there a place where they are cut and the holes are?
They come to us pre-made. You can see some over here. To our specification, obviously, and to our CAD design. These are some scrap ones that I can handle. So a big circuit board might look like that. All of the exposed metal is gold plated. That's less corrosion, and therefore we get a better solder joint. Typically a board will be rectangular to start with and then gets chopped down to the appropriate shape to fit inside the product, which gives us flexibility to do boards with curved edges and so on, even if it starts straight. You can see there's two layers on top and bottom, but also within the board there are further layers of copper tracks and sometimes ground planes and so on.
Within the board?
Yeah.
That's where the traces are, essentially?
Yeah, yeah, and sometimes there's lands or whole areas of copper to act as screening plates. Because a lot of our boards may well have a mixture of digital and analog electronics on them.
Okay.
So we have to be careful about crosstalk interference between those two forms, and we can do that with designing of the board. I think this was probably a 6-layer board. We go up to 8 layers on some of our circuit boards. Adds an extra level of complexity to the design, but it also enables us to shrink the board and pack more technology onto any given size.
Yeah.
We're not in the same realms, obviously, of shrinking boards to the way you'd get in a mobile phone or so on, but it's really works for us and means we can completely control where we want the components to go.
That's interesting. Now, older board technology would have the traces on the surface of the board itself, and you're saying these are sandwiched?
Yeah, and on the top as well. There are
they're on the top as well?
Yeah, not many on this board, actually. Good point. There's hardly any, no. Yeah, and the very first boards would have been just one layer of copper on the bottom, all through hole components. Here we've got a real mixture. I love this. I happen to know, I believe this chip is on 45 degrees like this, so that the tracks to the associated devices next to it are all equal length, because it avoids sort of asymmetric reflections on the digital data. So that's a new thing that happened a few years ago when we could put 45 degrees.
So the information is not taking longer to travel?
I think it's to do with reflections between for high-speed data, but not my area of expertise.
Yeah, that's really cool.
So yeah, that boards come in packs.
So those come in packs.
Yeah, they're hermetically sealed so we don't get any corrosion. Each board individually is inserted into the screen printing machine, which applies the paste. From there, the board ejected
one step in many, right?
Yeah, the board comes out, and it's not loaded up at the moment. But this is the first of our pick and place surface mount machines. Components are loaded up here, ready to be really just picked up and put onto the board. In this case, there are 12 nozzles on this machine. Uses suction to pick up each component. They're tiny, a lot of these, every couple of millimeters.
That's a lot of intricate work.
Yeah, and it uses the same coordinates as the CAD file that's used to design the board, so it knows where to put each of the components precisely, and it uses some optical recognition to make sure things are aligned correctly as well.
And this is this is unusual.
Yeah, I mean, if
to have this kind of equipment in...
Most people, I think for a company of Meridian's size, yes, in that there are specialist companies that will build circuit boards for anyone, and they may well have many of these machines. What's unusual is for a company of Meridian's size to have any of this, and we've got a complete line. This is all new this year. It's superseded what we had before. This is still capable of running and did as well for 15 plus years.
These are the old guys.
Yep.
Are these pretty much, they're still capable of running?
They still work, yeah. We run them in parallel, but most of the stuff's done on the new line now. And typically, we start with small components in the first machine, and then they might get a bit bigger. So we work up from single capacitors and resistors up to ICs. Now, strange enough, like edge connectors and multi-way headers and so on can be surface mount as well. So they're done here.
Okay.
And here and on the back of this machine, there's a cartridge that can carry some of the biggest components we do surface mount. Things like DSP chips and other programmable devices, CPLDs and so on. In fact, I think you may be able to see on camera some square sections there. I think they hold some of the big chips.
Oh yeah. Okay. Wow.
At this point, all of the parts are just held in place by the stickiness of the paste that I mentioned. So they carefully carry on up this kind of conveyor belt into the hot air solder oven, where it's long like this. It's not just, in fact, it could cook a reasonably good pizza.
I was going to say.
We have complete control over the gradient of the thermal of the temperature, so we can ramp the temperature up so it gets maximum heat here, say, and then we bring it down gradually and then apply heat again. This became more important recently, or a couple of years ago, when we started using some chips in a format called BGA, where rather than the chip having legs sticking out the side, the connections are actually on the underside of the chip, almost like hemispheres of solder. So once they're soldered, you can't see them.
Right.
And that gave us a bit of a headache, knowing have we soldered things correctly or not. So we had to get tighter control on that gradient of temperature. So we invested in this new machine. Here's some boards that have been through the process. In fact, not just once, but twice, because these...
And are these for...
Okay, yeah, these are Elipse boards.
Elipse boards.
Yeah. And as you can see, a lot of the components are surface mount. But we can see there are some gaps. The things that are going to have through-hole components on it, which will be applied later on once we know these boards are okay.
And how do you check?
Yeah, well, here we're not going to power the board up. It's not finished, but what we can do is, in effect, take a photograph of it. So every single circuit board comes through this machine. It's got a large camera inside, very precise, which takes a picture and uses optical recognition to check that everything's where it should be. So it knows what those boards should look like. Here we've got 2 boards on one card. And it goes as far even as well as checking their orientation and that everything's where it should be, nothing's missing. It'll even read the text that's printed on top of the parts. You see quite a big one there. It's upside down, but it's 4R7, which I think is a resistor value. It checks that that's what it should be. And if it's wrong, it throws it up as a potential error to the operator.
And some of these are just extraordinarily small.
Yeah, they're tiny, and the printing is often, as you can see, grey on grey. So it's natural. We do see failure reports coming up, and it's up to the operator to use their skill, their knowledge, their experience. And in our case, we're lucky; most of our guys have got lots of experience to judge whether the image is acceptable And if it is, they can pass the board. If it's something they want to add to the acceptable library, they can do that and make sure that any come through printed in the same way will also pass.
This is a big device.
Yeah, if you
considering
it is, I shouldn't say it, but it is a glorified camera. Inside we can see, I don't know if it's too dark for you, but there's a series of lenses there. And we can choose the type of light that's used to look at the board beyond the scope of human sight, so that we can actually, it helps us check the quality of the solder joints by the reflectivity of certain parts of the light spectrum. Hopefully, finding
how
that
is
everything's
static
good.
managed in all of these environments?
Well, I broke the rules by touching one board,
right.
although I did touch it by the edge. But the floor's treated. We do have the standard precautions of wristbands. Some people have heel straps and so on.
So you're grounded.
Yeah, yeah. It is quite a headache.
And then when it's done, it just slides on out?
Comes out here. And we know the board's okay in terms of what we've done so far. And it can move on to have other components added to it, yeah.
Wow, very cool.
Here you can see this is the manual repair station. So if at this point we do find any components that are incorrectly positioned, potentially the right people with the right skills can look to fix them. Obviously, some things can't be moved once they're soldered on, or you'd damage the board trying to remove them.
Right.
But we do that at this stage before we load more components on, because we may still have access to those tiny components at this point. Thankfully, nice and quiet at the moment, which means that nothing's failed.
No, right.
Not much going through either. So
we get back into some of the components
here.
here.
Yeah, got some. So in terms of, I mentioned components with legs on them, through-hole plated, through-hole components. Here you can see these are capacitors and so on. These ones are already trimmed to a nice short length, which are going to be inserted by hand into whichever board. And I may be able to see here. Again, these are ellipse parts. So this is a kit of parts for building an ellipse board. This circular carousel of components will be mounted onto this machine on this bench here. And here, the whole bench run by a program on the computer that knows which board's being built, knows which components are in these sections on the carousel, and rotates the carousel to present the appropriate component to the operator. We'll pick that part up and put it onto the board according to where this beam of light shines, and the light moves to where it knows a 10K resistor's got to go, or whatever capacitor, and then moves to the next one when we press a button. Or click
it's just an extraordinary amount of precision that goes into getting these parts into the right.
Yeah.
And orientation also, right?
Yeah,
I mean,
yeah. In this case, you're right. Yeah, yeah. The light actually stops at one end of where the component's going to go, showing us plus or minus. So diodes, electrolytic capacitors, and so on, getting the right way around.
Which you don't want to get that diode backwards.
No. What we're doing is what any manufacturer's trying to do. It's building it right first time. All rework is an enemy of quality. So by building boards right first time, we improve that. It's really important to us, given the nature and scale of the work we do building boards, because we aren't a mass production company. We're making batches of boards. We may be making 50 boards, but 150 is a large batch for us. Went to a mass production company, you make 100, there'll be one person doing the same boards all day long. Here we'll have someone working on something in the morning, and then doing 50 ellipse boards, then doing 20 boards from an active speaker or something like that. Although we have to reprogram in between and load a different kit of parts, this reduces the errors that would be likely to creep in by that chopping and changing. And we keep consistent quality up.
Yeah, I love the attention to detail. Like you were saying earlier, a large manufacturer of boards might check 1 out of every 100 or so.
Yeah. And that might suit them. That might be fine for what they're doing and their cost levels. And if they eventually test the finished product and find a fault, they're throwing it away or doing whatever they do, it's a few dollars.
Yeah.
Our boards by this point already have a lot of value. And it's better for us to nip that in the bud. And so we do, every board gets optical recognition, every board gets tested in-circuit tests, which we'll probably see in a while. And then we get functional testing on the board and potentially the finished product or halfway built product.
Which we're going to see.
Yeah.
Well, you know what I love about this station is all this high-tech technology, and we have a CD player.
I know the owner of this, and they've used this for many years. So
that's fantastic.
It's a vital bit of Meridian history.
That's really cool.
Now, in many cases, as you may have surmised, the parts put on the board there are actually just inserted into the holes. There's no solder involved yet.
Sure.
So the soldering happens in a machine behind us. We'll see in a second.
And someone might be wondering now, why not? Right, because if you've never soldered before,
right,
you don't know what kind of nightmare you can introduce into a board.
Soldering
by doing it.
is you're putting liquid metal onto a thing that's got lots of metal bits on it, and it wants to short things out and so on.
Sure. Yeah.
One of the interesting or useful things we do is we actually put all the boards, once we've had the parts put through, they've got these legs sticking out. We chop those off here prior to doing any soldering, because if you solder first and then cut, you're actually introducing some strain onto that joint, which on one joint isn't a problem, but if you do that consistently, it can be risking introducing a problem on that board.
Sure.
So we chop the legs off so nice.
So the board sits in here.
Yeah, it's
and it just gets
like
sliced.
a guillotine. Yeah.
Yeah.
It's then mounted onto a carrier to come up this conveyor belt, and when this is running, this is our wave soldering machine or flow solder. The board advances slowly. Initially, it's squirted from below with flux to degrease the board, remove any chance of the solder not sticking. And then the whole board is heated nice and gently, but up to a proper temperature, 250 degrees, I expect, something like that. And
that's Celsius.
Yes, yeah.
So Fahrenheit, we're talking even greater.
Or something, I don't know,
Yeah.
So when it's running, this reservoir here would be liquid solder. It's solidified at the moment. But even when this is liquid, it actually looks quite a lot like this. It has this sort of oxide, sort of residues on top. We don't want any of that stuff on our precious circuit board. So one of the tricks this machine has is as the board approaches this reservoir of solder, a pump is triggered, and that central section that's sort of V-shaped is deliberately allowed to fill up and overflow, revealing completely clean solder. The board, the underside of the board, just kisses the surface of that solder and is drawn by capillary action into all the nooks and crannies.
That's just amazing.
And if you think about, some boards have multiple, 96-way connectors on them.
Sure.
If it was you or I with a soldering iron, we would be there a long time, and the chances are we'd miss the odd joint or we'd connect to a bridge, all done in one go.
Plus, getting it to look that perfect as your boards do,
and
it's almost impossible to do with hand.
And even this looks like a crude process with this solder sort of spilling over, but actually it's quite accurate. It really works well. Now, because it does heat the board up to such a high temperature, there are some components we can't put on prior to this process. They would just melt. In our audio products, we use a lot of polystyrene capacitors, which are really sensitive to heat. They'll just melt. We also use components that wouldn't lend themselves to this process, things with flying leads, chunky heat sinks and so on.
Right.
So a lot of boards will have something put on manually after this stage, soldered by hand, which is happening here. Again, it's the Elipse board. And I learned earlier that this is a USB thing being added on, chip. So just doing the same again. This is a chance, as well as applying the components, we've got, again, an experienced operator able to cast their eye over the board and check if anything really untoward appears to have happened, if the soldering machine was playing up or something.
Yeah, that takes a lot of precision right there.
Yeah, it's...
Yeah, that's neat to see.
Cool.
And again, we have the Elipse boards.
Yeah, Elipse boards, and one thing to note here at this stage, every board gets a unique identity, a barcode, which means it gives us traceability through the rest of the process to make sure it doesn't get to anywhere before it's passed the appropriate tests.
And that gets applied in the factory.
Yeah,
a little sticker in there to keep track.
Yep, completely unique. And then the testing begins.
I'm digging all the lights on these machines.
Okay, yeah. I suppose we don't see ribbons. Yeah, sure. Guys, maybe they're going to come back. Chris, can we borrow your finger again? So this is in-circuit test, as it's known. Also ATE is sometimes referred to, automatic test equipment. Here we're going to do testing, but it's not for audio performance, it's not distortion, noise, and so on at this stage. We're just testing that we've built the board correctly. So this backs up our optical recognition testing earlier, where the board is going to be put into a machine that acts like a giant voltmeter or ohm meter,
right,
to measure points of contact to check that resistance is right between different places, capacitance, open circuits where they're meant to be, short circuits where they're meant to be. And it uses 4 flying probes, hence is known as the flying probe machine, to
is that what
do
you
that
call
testing.
It? The flying probe?
Yeah.
Whoa. Here we go.
Aligning
Yeah,
Boy,
cool.
Yeah, that's a lot of measurements in a relatively short amount of time.
Is it 10 per second? Something like that.
yes.
Count them.
Yeah.
Now,
Is this the count right here of how many it's done?
Yeah.
Yeah, so each one of those is every test that it's running.
And it's going to be 1,800 nearly.
That's it.
Yeah. That's a lot of measurements. Now,
So every single board
we'll go through one of these machines. Yeah.
goes through.
Yeah, so we're really keen, particularly keen to spot any serious errors, like a big short circuit or something that would potentially damage not just this circuit board, but anything else we plug into it when we undergo the next stage of testing.
Which is why you don't just power the board up.
Exactly, yeah. It's fast in that it's doing lots of tests, but it's slow in terms of mass production terms. What's this going to take? A few minutes? What are we up to? 1.5 minutes? 1.10 minutes so far? So, yeah, in a mass production environment, you wouldn't afford this amount of time on every single circuit board as we do. But for what we do, for our quantities and the value of our products, we think it's worthwhile.
If you were doing that by hand, though, you might get one board done in a day. Yeah, I mean, here's for everyone at home. If you're not familiar with this stuff, that right there is the probe tester that you would use to find continuity.
If you want to,
or
Tom,
lack therereof.
Pass the camera. We'll film you doing one.
Yeah, no, that's okay.
Have you got a big battery?
Do you have like a week?
So yeah.
Yeah, doing it that way is not only a pain, but you'd always be second guessing yourself.
Yeah.
It's not easy
No, this
to.
is accurate. I mean, this takes time to program, but again, you can imagine where that's probing is again stored in our CAD information. We designed the board, so we know where everything is, and with some, I'm sure, some adaptations to suit the process. That's where it's again common data to the design of the board and the optical recognition. And
this is doing it basically blind. It's just going off of the instructions that you've fed it.
Yeah. I mean, if this finds a problem, there's the next step is how it presents the fault. And in the old days, this would have been just a strip of text, and you had to use circuit diagrams and lookup tables to find out where R1 was or so on. But now we're linked through to a computer-aided repair system that actually on these monitors can throw up a graphic of the board suggesting where it thinks the problem is. And of course, because you've mentioned tracks, because tracks run sometimes from one side of the board to another, well, not that from one side of the board to another. If we have a short circuit that appears to be here, it might actually be over here. So we've got tools and methods for finding that. Hopefully, it's not buried inside the layers inside the board.
Well, then there's a problem.
Yeah. Then it's
you have to throw the board out. Yeah. I mean, and I guess in the olden days, you would take a wire and solder it on one leg and lead it down to another and kind of do a hack around?
You are referring to my past, yeah.
Can't do that though if the traces are all internally and
yeah.
plus you're selling product that
No,
I don't think anyone would be too happy about receiving.
Sometimes that would happen in a testing part. Sometimes it's to satisfy your knowledge of where the fault was, and then you still wouldn't use the board because you'd wrecked it. But at least you knew that what the fault finding process was,
right,
and what to suspect next time if it crops up, which isn't dissimilar to what this can do. In effect, it can learn where the faults are. It's a system that can learn from when it finds faults. It will suggest what the problem might be next time.
Right.
Cool.
Yeah.
So every board goes through this type of testing.
And that's what you were testing there? That's
yes. So that's given me all the test data back, which I need to look into now.
All right.
And that's actually a good look at how the solder is laid.
Okay, yeah, that's one.
By your machinery that's over there. I mean, look at that.
Yeah.
How intricate that is.
And we've still got stuff to go on. Is that in
got,
wall speaker?
This is 3200.
Oh, right, 3200, yeah.
Yeah,
so it's still got big
third stage.
Yeah, so there's stuff.
Soldering to do.
Oh, stuff.
They're large transistors, aren't they, or output devices? Yeah.
Mm.
Cool.
Thank you.
Thank you.
Thanks, Chris.
Appreciate it.
Probably can scoot over that because it's not so common.
There's so much to take in here. It's neat to see that machine in action.
Yeah, I'm glad you did. Yeah, it's a shame about the session. Hi, Bart.
Hello.
This is Todd. He's come to see how
Hi
you
there.
build ellipses.
Hello.
How are you?
All right, you?
Just fine, thanks.
Are you okay for them to film you doing thinking? What's about to happen to that one?
I left it for.
All right, so you can fit the drive units.
Ah, right.
Here is the unit, which is how it looks inside.
Okay, so you can see inside
Yep.
of the cabinet. One of the interesting things about the design of the cabinet is it's almost two designs in one piece, because the outside is obviously elliptical, particular shape, but the inside is shaped to suit the acoustic performance. So we've got completely isolated chambers between the wide range units and the bass drive.
Mm-hmm.
And the rest of the shaping helps reduce resonance. So we've got extra built-up areas where we need it, and to break up any standing waves as well.
Okay. Yeah, seeing this is really cool because, like I was saying to you earlier, it's easy to imagine a large factory,
a big machine,
churning these out, right? But this is all handmade.
Yep.
You have units over here that have been built, it looks like.
Yeah. What stage are they at? Have they got electronics on them? Or
those actually don't have electronics.
Oh no, they're just cabinets. Yeah.
Oh, they're ready to be housed with electronics.
Yes.
Yeah. So they're at that stage. Oh yeah, and there's the electronics.
Oh,
over there. So
there they are, right over there, waiting.
So yeah, those would have been tested in that state. Do you pressure test these or anything, Bart? The cabinets?
We have some which was already tested, but
right.
we can show.
No. Sorry. Just what we're saying is we test the electronics, we sort of test the cabinet, put them together, and then the whole thing's tested.
Yeah.
Mm-hmm.
Yeah.
Okay.
Wow, it's a lot of stages of
again though,
making sure that everything is correct.
Yeah, that's it, and hopefully right first time, not having to take them apart.
It's neat to see, just hand assembled.
Yeah.
People, caring about what they're doing and everything. It's very reassuring.
I mean, the other thing I have to remind myself is, of course, this is an acquired skill. I've been dexterous, and although we're in a factory, you can't just walk off the street and start building Meridian speakers.
Right.
Even having that feel for when you're putting a screw in of how much resistance should you feel before it's a problem.
Does this? I'm assuming this driver also would give you a little kick if you tried to over tighten. Does it have a?
It's preset torque over there.
Okay.
A preset torque.
Yeah. So we have the.
Oh yeah.
All the.
Oh, there it is. Okay.
1.22 Newton meters. Ooh.
Yeah, I could see somebody with just a regular old screwdriver just cranking that down, and yeah, don't do that at home, right?
Yeah. And actually, it's the same drive unit family as used in ceiling speaker as well.
Oh, really?
Yeah,
We
yeah.
have some of them
Yeah.
right there.
They're slightly different, but where are you pointing at?
320s at next to the wall.
Oh, right over the back.
Yeah.
Okay, yeah, yeah. And yeah, the racetrack base drive described from its shape. Again, a shape of that's. If it's not the same drive unit, it's very similar. It is the same drive unit, isn't it? It's That's a 320.
Yeah.
Yeah. So it is the same drive unit as used for the base in one of our in ceiling speakers.
Both of them are using 320,
Yeah.
and those are used on 5200.
Okay. Yeah. Yeah.
Then you have, it looks like a wooden holding bracket.
Yeah,
I don't know
that's
what you would call that.
Just a jig, I guess. Yeah,
A jig.
Yeah.
Yeah. That looks like it was custom
Yeah.
cut just to hold the speaker.
We've also got a 3D printer as well now.
Oh, do you? Oh,
which
cool.
we use for small production tools and stuff like that. And
we have one of the jig for actually putting two parts together.
is that?
Yeah.
Okay, yeah. So we've made that in house.
Oh, wow. Okay.
I don't know what part it's for.
That's to put.
Oh, okay. So this is the keypad.
Yeah.
It's on top of the product.
Okay.
So it's a small step, but it's one thing we didn't have to ask someone else to make for us.
Sure. Right.
So we take that DC valve and stick together.
Okay.
Okay, so it aligns it.
And that way you know it's mounted correctly.
Yeah.
Yeah.
Cool.
Oh, that's neat. It's very clean.
Yeah,
Throughout this entire space.
Yeah, and this is it's strange, but this is about as noisy as it gets. As well.
Really?
It's always we're lucky. We've got more workstations than we have people working, because the workstations are set up for different tasks. So someone will be doing one thing in the morning. I mean, at the moment, I think Bart's building Ellipses full time, but previously has worked on speakers, and depending what we're building at any one point in time, people will move to the workstation required.
Yeah.
So that's pretty much done.
Yep.
And that's the first of the test, which is phase test. We make sure that every driver is moving.
Left, right, and bass.
If we press the middle one and any of those are moving, then we know that there is
A leak.
yeah,
Cool.
leak
Okay.
inside the tabs.
Okay.
Mhm.
Yeah. Nice simple test.
That way you make sure they're sealed from each other.
Yeah.
Like you can see here inside,
Yes. Okay.
and
Wow. So not just separated, but truly sealed
Right. Yeah.
from each other.
Yeah.
like inside here, for example, yeah.
Oh, yeah. And how is it sealed? Is there a little like rubber
like,
gasket or?
Special
Yeah.
called black tack.
Okay. Yeah. Yeah.
So it's like
It's quite soft.
Is it smushy? Yeah. So you can just like.
yeah.
Ooh, that is tacky.
Yeah. Cool.
Yeah, you wouldn't want to have that like rolled up into your hair or something.
Ruin your best shirt or something. So
Wow.
they're the
Thank you.
electronics.
Thanks for showing us.
Thanks, Bart. So there's the electronics section. Let's see, we've got a switch mode power supply. Very compact, lots of surface mount. I'm thinking this is to do a streaming, but I'm not the resident.
Here's the backside.
The connections for the audio inputs and the network directly to the circuit board, which again, as well as making it nice to build just a single board, we don't have any flying wires for that. In fact, the only flying connectors are through to the cabinet, and that's carrying the audio to the three drive units. And there's also going to be a ribbon cable on one of these, or both, going through to the control panel on the top.
Okay. And so that all gets connected when...
Yeah.
It looks like, so these bottoms are going to go into...
Yeah.
Overseeing over here.
Yeah. Okay.
Yeah.
Okay, cool.
Not to mention that's an amazing sounding speaker, which we'll talk about separately.
Yeah, that's why we go to all the trouble. Yeah.
Yeah.
Oh, so right, another part of testing. I forgot about this.
Ah, see the stethoscope.
Yeah.
It is very medical-like over here.
Yeah. So we've got a base sweep, and again checking for air leaks.
Checking all the screws.
And the main seam.
And again, every single one of these goes through this test.
Yeah. See the base drive working.
Yeah, it really is. Is that particular driver custom just for this particular unit, or
No,
is that
no, we use it in the DSP320 ceiling speaker.
Okay.
Somewhere on that shelf over there. So we know it well. And it worked for the job. If during the design phase we thought we needed something different, we would have.
So now at this point, it's ready to be put together with electronics.
Right. Okay.
Then it's
Right.
going to test.
Yep.
And then if everything's fine, it's packed.
Yeah. Cool.
Wow. Cool. That is very cool.
Meanwhile,
Lots of, yes.
Aaron's building a DSP5200.
200 custom.
This is a custom color?
Yeah. In fact, our black is now our only standard colour. For quite a while we had black and white. We had other colours previously, but the trouble was when we say white, everyone's got their own version of what they think white is. And this is probably on the extreme because this is a cream.
Yeah,
But
it is. It
we did perfectly bright white, and it was, oh no, I want something a bit more subtle. So it's okay. We'll move white to being one of our select colours, which, although say select colours is any colour you like, because we'll colour match anything. We have a book of swatches, to sort of provoke the thought
But
process.
you could do any finish that you want, essentially.
People match them to their decor, the furniture, to their cars.
I was going to say, you could put like an automotive
Yeah, plenty of those.
finish on this.
Yeah. What was the? I can't remember what car it was. Was it a blue one we did? That was a present for someone. Was it someone buying it for their partner and they didn't know they got the speakers to match? It might have been, yeah. Yeah. Which is quite nice. Yeah, by the way, I got you these as well.
I know.
And we do
It's a nice gift.
We do some colours which we're not interior decorators or designers, and you look at some colour and think, oh, that looks really drab and dull, and then you see it in the finished room and you think, that's why I'm not an interior designer.
Right, exactly.
It might be a kind of mid-brown colour, and you think, wow, who'd have that? But actually, it works perfectly.
I like the little standoffs or inserts. Yeah, so that's how you can handle the speaker without.
And it aligns it as well, to some extent, not too much.
I've always wondered how that worked, because when you're at home and you're pulling out a driver or something, it's awkward.
Yeah. I mean, these have just gaskets behind them now, don't they? They don't have any group. But even here, the adhesive on the gaskets, single-sided adhesive, that over time will creep, and it can mean the drive units are harder to remove. And I mean, our people who service our products will know sometimes you might even be better if you want to change that drive unit. You might take the tweeter out so you can get some sort of pressure from
to
behind,
kind of
or vice versa.
Yeah, that makes sense.
Yeah, you can see here, as well as the drive units, a display on this particular speaker has a digital display, and the ribbon cable feeding the display runs through that tube to the back of the cabinet where it connects to the electronics modules. Oh, sorry, it's a special edition.
Boy, that looks sharp. Is that custom also, the color of the...
No, they're all chrome unless you specify black. We've done
so
both,
it's black or chrome?
Oh, sorry, not chrome, silver coloured, I should say, yeah. It's aluminium, I think. But it's, as well as looking nice, it is an integral part of the clamping mechanism.
Yeah.
It adds rigidity and reduces resonance. Not that it's, we've you know, it's quite a chunky drive unit to start with, the edge of it.
Yeah. Yeah, I love that attention to detail again.
And the electronics that's going to go in this is this here.
Oh wow!
Right.
So this goes on. This is the backside of
Exactly, yeah.
that guy over
Covers almost the entire back panel, and again, really.
So we're looking at the power.
Yeah, power transformer.
Power transformer.
Input connections, mains inlet, and then the amplifier board, which in this case has got 3 amplifiers next to each other, one per drive unit. They're fed from under here is the board, the control board, which includes the computer, the brain, the D to A conversion, and the DSP and electronics as well.
Sure.
Covered with the shielding can, and we've got a phase test going on.
We're doing. So this is
A phase check.
Phase test.
Yeah.
phase test.
To make sure I've watched.
This is marking your own homework. Yeah.
There we go up.
Plus, yeah.
You know, we laugh, but I've actually had speakers arrive.
Wrong way around. Yeah.
Yeah. Yep. Wired incorrectly. Not from you. Not from you, but.
We do test quite a lot. We test all the way through.
Yeah.
Mm-hmm.
You know, so
Yeah, and each one, so that makes a huge difference as
Yeah,
to
yeah.
what is coming out.
Yeah.
Look at these beauties over here. Wow.
Okay. Yeah. So these are the cabinets for the DSP8000XC, our flagship loudspeaker.
Mm-hmm.
Not quite. So this will get a steel plate over that's finished on this, held on by those 3 circular magnets you can see,
Yep.
which acts as a waveguide. This actually allows us to have frequency response up to beyond 40 kilohertz, down to the waveguide. Because even these tiny ripples and stuff, the screws would interfere with that. You don't get a good dispersion.
Mm-hmm.
So with the base cabinet with its 3 pairs of horizontally opposed drive units, which work on each other to basically, again, reduce low frequency resonance.
Inside the cabinet.
I mean, if a drive unit is mounted in a cabinet, what we often forget is there's as much energy coming backwards off the drive unit as there is coming off the front. That's physics is equal. And in a single box, in a speaker with in a box, the drive unit, that energy coming off the back will slam against the back wall to cause it to resonate.
Right.
Here, waves come from the back of the speakers for drive units, hit each other and are dissipated. So it's a longer journey before they get to the walls, and therefore they've got less energy. So we've got less of a problem to start with.
And there's 3, and the low end output on that speaker has got to be.
I think I have to check. I think is it 18 hertz? I think we quote in normal.
Yeah.
I think it's 18 hertz.
I believe it.
Yeah.
I mean, those are 10 inch.
Yeah. What are they?
Or not.
200. Yeah, they are, aren't they?
They look
Yeah.
like 10 inch.
We often say it's the best subwoofer Meridian have ever made, and it's true. You'll see some evidence of that later when we do a demo for you.
Beautiful.
Okay. Right. So
It's funny that song playing is the first song I ever heard on CD.
what is
This
it?
one.
What?
Yeah.
Erasure. Yeah.
How is it? I don't know what the first song was.
Mine was Pet Shop Boys, West End Girls.
Oh, right. Good track.
Yeah, that was a moment I'll never forget.
There you go.
That kind of realization of, wow, it sounds really good.
Well, in 1987, when I started work here, we used to test all the CD. We had. Do you remember CD singles?
Oh yeah,
Tiny little CD.
those little guys.
Well,
yeah.
before they were invented, we took a normal CD and chopped it down because we had to play a CD on our player, the 207 CD player, first product I ever worked on. And there was an adjustment on the laser intensity that you could, or one of the adjustments, that to get to it, we had to have this cut down disc because you put a screwdriver down inside the player next to the disc, adjusted it. And it was a Alexander O'Neill track, name escapes me, and I must have heard it about 4,000 times.
Now you hear it in your nightmares, probably.
I don't want to hear it again. Yeah. So in this room's where we test speakers, and that is in our case every speaker. So every speaker we make gets tested.
Mm-hmm.
Shame it's not many.
You can hear the change just
Yeah, we've got. It's not pure anechoic, but it's just a way of cutting down, so semi-anechoic, cutting down some of the major reflections. Speaker goes through a variety of tests. Every one of them is aligned with the microphone, which is connected through to our audio analysis kit. A short blast of what sounds like white noise, is actually pink, I think, is used to do a frequency analysis, so we can check the frequency response of every speaker is as it should be, and the same as every other one of that type of speaker ever made. We then perform some tests which are more human. We listen to some bass sweeps generated from a tone generator to check for any unwanted rattles or buzzes, things that sometimes a computer would miss. And we also play a short piece of piano music, because we found a piece that's really rich and really rich in mid-range energy. And it sometimes buzzes something other tracks don't reach. And we found that out because it did it at an exhibition once with a pair of our speakers. So we said, right.
You heard the buzzing?
Yeah, we heard it.
Okay, so that's definitely the one you want.
Yeah, and it passed our test, that speaker. So it's okay, the computer missed it. We need to play that. And since that day, 25 years ago, I think every speaker has had that piano piece played through it.
Wow.
And also because our speakers have got a microprocessor inside of them, because they talk to each other, they act as part of the system. We perform functional tests, make sure they wake up when we tell them to. That the an interesting thing in a Meridian system is, although you might think you're turning the volume up on a tablet or a volume knob, if it's got Meridian speakers, it's actually the speakers that are turning up the volume. The control is just the control sending signals, and the speakers are turning the volume up and down. So we've got to make sure that's synced up and working.
Right. Yeah.
And it should be that should be transparent, totally invisible to the end user. They will have the the perception that they're turning the volume up on the knob, but actually it's sending a signal. But again, 100% testing.
Yeah, that's cool. Yeah, I mean, perception's everything, though, right?
Yeah.
That's neat. Neat room.
In fact, these ones are destined for America because they've got a red dot on them. That's 115 volt. Maybe we've got you a little leaving gift.
Yes. Good luck getting that on the plane. Look at this guy behind here.
Okay, yeah. So that's the predecessor to our flagship. Bit of an old war horse, that one.
Yep.
So that's the DSP5000 in its earlier guise, which was the
hiding behind the door there.
Yeah.
Yes. Are those slightly smaller drivers or different drivers?
They're different drivers. They're
different drivers.
Nominally the same diameter, but they're much smaller. And
Yeah.
the magnets on the new ones are bigger. In fact, we had to redevelop the cabinet to get them not to. Oh no, it's a different speaker. So yeah, these sounded fantastic, and they still do. But when we switched to the new ones, suddenly these didn't sound so good. It's like, how can that be? Yesterday they sounded like the best thing I'd ever heard, and now we've heard something better. Always the way, isn't it? Okay.
Very cool. Sounds like somebody's getting tested.
Yeah. And then you see some examples of installation products. So this is our in-wall subwoofer. This is the thing this illustrates is, as with all of our in-wall speakers and our in-ceiling speakers, it's a really narrow fitting depth.
Yep.
Maximum 4 inches, 100 millimeters, in this case slightly less, which is a real boon when you're chopping holes in walls, stud walls, and in particular when you're starting to deal with brick walls and so on.
Yeah.
It buys you space. This is a great frequency response, really good bass performance from something so shallow is a real bonus. Not having to mount a separate box remotely or something up in the ceiling. And,
sure. It's big.
Yeah, and it's designed so that if, depending on the nature of the installation, all of that would be behind sheetrock, as you'd say in the US. And only this part and the electronic section lives underneath would be exposed, or potentially, but again, maybe fabric covered, whatever. Various ways of mounting it in the wall.
Yeah, that looks like it's ready to slide right in stud bay and live a happy life.
Yeah.
And that's sealed.
It is, yeah.
Correct?
Yeah. Again, because it's an active speaker, like most subwoofers, we're able to shape the bass to suit that cabinet so that we get the response we want.
Right.
And as with all our subwoofers, the in-room ones as well. You can set the tone to either suit music or movie. And some of those decisions you might not make until you're actually at the install and
put it in and see how it's going to
calibrate and see which works best. Yeah,
which is how it's going to resonate in your own room.
Yeah. Okay.
Got some packaging.
Yeah, the final stage after we've built and tested everything is to pack the product. We pack it with the right accessories and so on. This must be for one of our bigger speakers, because here we've got, these are the accessories you get with the DSP8000XE and the DSP9. This is a Bluetooth module, which can be used for streaming, but also allows you to get to all the setup on the product. And these are two analog input modules, which is supplied with, because our speakers are purely digital, this converts them into being like a standard active speaker.
Oh, that's interesting.
So you lose all the flexibility of the DSP controls and so on.
Sure.
That some of the things are still going on in the background, but it basically just gives you an analog input.
Okay.
And one of the purposes for this is to enable dealers, as much as end users, to demonstrate the product against something else they may have heard already, or with someone an existing preamp. I mean, we want them to go down the digital route and actually embrace fully digital system.
Sure.
But this is a way of talking to the analog world.
Sure.
Okay.
It's nice to have that ability to make a switch up.
Well, we had dealers saying, "Oh, I would like to sell your speakers, but I can't demo them against brand A or brand B because I haven't got your preamp or whatever, our control unit. So, okay, you've got this now, and you can just unplug whatever you're feeding into whatever power amps you're feeding them." It's quite an extreme way of doing it.
Got the factory
stickers, yeah. I realise we haven't looked at the test department.
Test department.
I wondered if Bart was ready to stick a Elipse in the drawer. Yeah. Do you want to see that?
Check it out. Yeah, sure.
Bart, can we see you putting the Elipse into the test bay?
Yeah,
Because I saw it. Yeah. Do you want to take it out and put it back in?
Sure.
Oh, look, frequency responses as well. Looks techy.
Yeah, look at that. So do you have the same kind of microphone that's in the other room?
It must be.
It's inside.
Yeah, it must be similar. Yeah, it must be similar. It looks like the same package on here.
Yeah.
So look, D-scope. Yeah. So I think so. Yeah. So,
That's the toughest part, the blind plug-in.
So here the Elipse is going to be inserted into this drawer-like contraption, puts it into an anechoic chamber, which we've built especially for testing Elipse.
It's going to slide right on in there.
Yep.
Okay.
You just need to wait for.
Oh, that's the
blue
boot up. Yeah. It's
booting up?
Yeah, 30 seconds, and it's a proper 30 seconds.
Takes its time, huh? So this is the final step for this speaker. It doesn't go over into the other room.
No, that's right. Yeah, this is instead of that. Yeah.
So wake it up, slide it in.
Is there a musical test that's done with it at all, or is this
not in this case? I don't think.
Yeah. If its frequency response is looking
so that's
spot on.
If you want, I can open the drawer.
No, that's okay.
Loud.
Yeah.
No, keep it closed. What's it get, Paul? Got
So this does get a 24-hour soak.
Yeah.
So we listen to the full home soak track.
Okay.
Oh right. Okay. We've got a soak is our word for burning.
So does it really?
Yes.
Yeah.
High volt as well.
Okay, and we've got a specially mixed track that's it's hissy treble, some music, bass,
white noise,
clicks.
DC. So
Yeah.
it does shove, sort of.
So it plays 24 hours.
Again, the Meridian, like anyone in this industry, we're trying to find out if the product's got a weak spot,
Right.
and therefore we find it, the customer doesn't.
Right.
And
Make a lot of people happy that way. Because no one wants to buy a new product and then
well, it's easy for us.
have it fail,
Easy for us to deal
or
with
not
that.
work out of the box.
And in here, what happened? Was that a quick frequency response?
So basically what that does is it gets the speaker ready, we turn off image elevation, we turn off
Oh, okay.
bass and space.
Oh, okay, yeah.
So that is totally
Flat sort of thing, yeah,
flat.
yeah.
It then does a full frequency response, so that sweeps from, I think that's about 35 hertz to about 20k.
Yep.
It does a full frequency response, and then gets high pot tested.
Okay.
So the flash test, that sort of
Yeah,
thing.
this is the safety test on the main side of things to check that, as well as performing right from an acoustic point of view, it's not going to electrocute anyone.
Yeah.
So it's tested for earth leakage, isn't it?
Yes,
Yeah.
earth
Yeah.
leakage, so that's why that's there.
Oh,
So
okay.
we actually
Right.
use where the rubber bumper goes.
Oh, okay. Right. Right.
So that's totally unpainted. We use that, and that's our connection.
Oh, that's the connection. Yeah.
Yeah,
Yeah.
it's quite nicely done, isn't it?
Yeah, it's cool. Yeah. Yeah.
And I see you have your 3D printed
More 3D printing. Yeah. Yeah.
part that you made.
Yeah, there's lots of 3D print stuff around.
Yeah. It's king of 3D printing.
Oh, really? Is that your?
I didn't design that. I've got one at home. But
Yeah,
a lot of
you-
us have, haven't we?
Yeah, not me, but yeah, no. Yeah.
Yeah, all of the test guys. If you come in there, we've got 3D printers.
I know
at
Chris
home
upstairs
without-
has,
Oh,
yeah.
that's good. I mean, you need your special tools to make your job easier,
Yeah.
right?
Yeah.
And home life.
Yes.
Yeah. So after that, it would just be basically cleaned up and
Yeah, so
checked,
basically the
unpacked.
whole idea is it comes into here, it goes into there, then it goes down the line. So it's just out
And
the
just
door.
gets packed.
So these guys are tested and ready to.
Yeah, so where is that we use?
No, they're storage of
we
cabinets.
use
So
that storage. At the
yeah,
moment,
yeah,
but
they're-
now
they're-
that's
they've
what
got
they
electric.
are, they're ready.
Oh, down
Oh,
here.
right,
These.
okay,
so
yeah.
these are the
yeah, they've got feet on them. They're ready to be packed.
finished products ready to go.
Yep. And
Wow, that just sounds so good. That speaker.
he heard it earlier.
Oh, okay.
I heard a
yeah,
demo and
It's cool.
really impressed.
Have you had the demo of the cinema?
No, not yet. It's coming. Okay.
It sounds interesting.
Cheers, Paul.
Thank you.
Yes, no.
So this is where we perform functional testing on circuit boards after they've been checked for that they're built correctly. We can test they're going to actually perform correctly. Distortion is good, frequency response, noise, any other measurements. We sometimes have to measure levels of jitter produced by digital circuitry. Very much a case of different tests for different products, and the skills that the test engineers here have is being able particularly to interpret the results when something doesn't pass. Because when you press a button and it passes,
It's
anyone
fine.
could do that. Yeah.
Right.
But when something's not right, okay, what is it? Can I fix it? Does it need reworking? Can I fault find that? Do
Sure.
I need help from the engineering team upstairs?
Which, by the way, you pointed out the engineering
Yeah.
team.
Up here,
These portals
eyes looking down.
are the offices for the right.
Yeah, so that's our engineering team, which is hardware, software, and everything in between.
It's quite an intricate. This is all power. These silver.
Yeah, and some data as well for networks. We've got some areas of network which are completely hived off from the outside world because we sometimes have software that will automatically update everything that's on the network. And if we've got a beta version of software this is for our network equipped products, we might want to update some stuff, but not everything in the building.
Right.
So it's an IT challenge having this sort of separate hived off area.
So I mean, essentially, you can move these departments around to any configuration you want to fit whatever manufacturing needs you have.
What we ended up doing, we did a move around a little while ago. We decided that although the test department, it feels like the process for most products would be very linear, as in circuit board building, circuit board testing, load it into a chassis, maybe test it halfway through building, finish it, test it. That idea that we sometimes test boards and then the product as a halfway built assembly and then as a finished assembly, we realised we were better off putting the test department in the middle or near the middle of the building, and things kind of star in and out of it, rather than doing the classic Henry Ford model of the production line.
Just going on. Yep,
Yeah,
right.
because things come in and out a couple of times. And yeah, it suits us quite well. So things might be built there, come here, go off there to be tested, and then they might come back here to have a final test, which is typically done with the product complete, with all its outer casing on. So it looks like it's in the same form that the customer is going to receive it. And we will press buttons and we will handle it in the same way as a customer would. Again, humans are very good at finding that little thing. We hope there's no cosmetic issues by that point, because plenty of people have looked at it.
Right.
But nothing's going to
Well, it's certainly handled enough
Yeah.
as it goes down the line that
Oh yeah, I mean, I say
defects would be
handling.
seen.
Most handling means actually being moved on a trolley or in a carrier or something like that.
Right.
Particularly with painted surfaces and glass surfaces and so on.
You just wouldn't want to be the one to ding something because
Oh,
I think
like
everyone would know exactly who did it.
There's I think a lot of companies in our line of work, we do have a no blame policy. So if it happens, it happens. Talk about it. Tell people. We'd much rather that happened
Then
than
you try
anyone
and
trying to
hide
hide it. Yeah.
Yeah.
I think we've banned black marker pens.
Oh, that's great.
So yeah, that's the sort of connectivity. Again, this is a surround sound box we looked at, the digital theatre
Oh, right. Right.
controller, and in effect we're converting in this case these analog inputs it's doing everything at once, analog inputs both on RCA and via these DB25s into digital outputs on our speaker link connections network. Now you or I could do that by plugging a pair of leads in one at a time, or left and right, and checking to see what. Here it's multiple connections, a bunch of switch gear, and a custom program designed to check every channel with crosstalk against every other channel, and the amplitude and noise. And as I said, the skill for the test engineer here is interpreting any results should it throw up an error.
It's impressive.
I can see here we've got sampling rate of 88, so that's doing upsampling on something. There was a frame. This will be some form of jitter. That's probably the end of my comfort zone. And of course, you can see, I think there will be noise measurements going on there on a 1 kilohertz tone.
So this is just set up to run, and then someone will come back and check.
However many
check the
minutes it
results.
takes. Yeah. Some test kit, as well as having the external connections on the product, sometimes we need to make special measurements inside the product. So again, working with the engineers, the guys might say, oh, I need a test point here somewhere to measure that voltage is correct on this chip. So
Sure.
we can design that into the product. So there is some design for test as well as design for making the product. Crossover. Okay.
Whew, that wire loom over there is.
Yeah. I wouldn't want to be the one. You say
That looks like a nightmare in the making right there.
soldering. Yeah, it's like and look at this, a very homemade Vera board. You recognise that stuff you use for home products. I wonder if that's. I know it's going in because it's clean. It's all new. Oh,
Yeah.
I'll tell you what. You see that word load. This is going to be for dummy resistive loads to emulate speakers, so that things with power amps we can drive them hard without having to listen to them.
Okay.
In fact, we've probably got something. Oh, there we go. There's one. There's a case in point. So there's big resistors on a heatsink.
Yep.
That's pretending to be a speaker, or pretending to be many speakers. And so we can, in fact, yeah, because William was testing those power amps from earlier.
So you can test the amp, yeah.
Yeah, so we can drive it. It's not warm. But yeah, that enables us to give amps a hard time. Because part of our testing will be to deliberately drive an amp till it shuts itself down, protects itself, because we want to test the protection circuit.
Right.
And then once it's cooled down and it comes back on again, we want to check it comes back on. So yeah, we don't want to be listening to the signals that need to do that. And
These
so,
capacitors are huge.
dangerous.
Yeah, I was going to say, be careful around those.
Manual handling. Your hair's got shorter. Did you touch one of them? 30 years of testing them and you'd avoided it until that point.
I mean, you hear about people manually discharging the old CRT monitors. Have you ever done that?
No, but I bet Colin, who used to work here, did that.
But I've heard that alone is
Right.
just like a massive, you
Yeah,
know.
I bet. Yeah.
I think I'd be messing around with that myself.
It's like a graveyard of a test script. Cheers.
Thank you.
Thanks, William. Okay, what do you reckon? Much sharper.
Yeah, fantastic.